welcome. We are starting a new chapter on probability, so let's just go over some of the basics of probability when we get started. First of all, every time that you do something that we're going to talk about the probability of, it's called a trial. So an example might be flipping a coin or rolling a die, or you might be interested in something that's more important, like will you have a boy or girl when you have a baby, okay? Or there's lots more applications that are even more important than that. Okay. Here's what is the sample space? Sample space is all the possible outcomes. So what are the possible outcomes of flipping a coin? Easy, you could get heads or tails. Possible outcomes of rolling a die, you could get a 1, 2, 3, 4, 5, or 6. Possible outcomes of having a baby, you could have a boy or a girl. An outcome, an individual outcome, I'm having trouble here. An outcome would simply be what you get. So after you perform the trial, you might get tails, or you roll the die, you get 6, or you have the baby and you have a boy. Now look at event. Okay, the word event is used quite interchangeably with outcome most of the time. However, take a look at this over here. What do you see? Okay, in this trial, we were trying to see what number we would get when we roll the die. How likely it is that you get a 4, for instance. In this one, we're trying to see how likely it is that we get an odd number or an even number. So our sample space is the same. Our outcome might be a 6, but our event would be we got an even. Right? So there are 3 different outcomes that would give the event even. Hopefully that's clear. Now, just as a quick review on probability, let's say we're doing the experiment of if you have 3 babies, how likely are you to have 2 girls and 1 boy? This is going to be a thought experience. In trial 1, okay, to find out the answer to that probability, the first thing you're going to need to do is write down all the different ways that the 3 different trials could come out. So I'm going to go ahead and pause the video and write them. Okay, hopefully you see. One way we could have boy, boy, boy. We could have boy, boy, girl. We could have boy, girl, boy, etc. Hopefully you can see that there are a total of 8 different ways that this experiment could come out. Total of 8 ways. Okay? So to find the probability that we have 2 boys and 1 girl, we look and see how many of these have 2 boys and 1 girl. 2 girls and 1 boy. 2 girls and 1 boy would be here, and here, and here. There's 3. So there are 3 positive ways. So our probability would be 3/8. Okay? This is the basics of probability. It is very tedious to go and write down all the possible ways, especially as the numbers get bigger. So today we are really going to talk about faster ways to find how many possible ways are there for the trials to come out. Okay? Learning objective. We will be able to use the fundamental counting principle to find all the possible ways that multiple events could occur. And do pay attention to the language objective. You need to be able to explain the difference between an independent and a dependent event. Here's a good problem. A cafeteria offers drink choices of water, coffee, juice, and milk. Okay, I'm just going to write this out. Drinks, and these are my variables I'm going to use. We've got water, coffee, juice, and milk. For salads, we've got pasta salad, fruit salad, and potato salad. I'm going to write a P-O and a P-A so we don't get those confused. How many different combinations of drink and salad are possible? Okay, you have probably seen this before. Have you seen people make a tree before like this? So first people have to choose a drink, water, coffee, juice, or milk. Then they have to choose a salad. There are 3 possibilities for each, right? So you could end up with pasta, fruit, potato, pasta, fruit, potato. Let me pause it and I'll write it in. All right. Each of these pathways represents one possible way. You can see that there are 12 altogether. So there are 12 altogether. How did we figure that out? Well, for the first trial, there were 4 different ways. For the second trial, there were 3 different ways. Can you see that 4 times 3 equals 12? Yeah, simple. A little bit more complicated. Janine has decided to buy a pickup truck. Her choices include a V6 or a V8. So first she has to choose the engine. And how many different possibilities are there? 2. She can do the 6 or the 8. Okay? Then she has to choose a cab. And it's either going to be a standard cab or an extended cab. You know what? I'm going to save this for later. Okay? And then she has to choose whether it's going to be, what kind of drive it's going to be. So she's going to have to choose 2-wheel drive or 4-wheel drive. Let's make a tree. First she has to choose the engine, either 6 or 8. Then she has to choose the cab. So she's got standard or extended, standard or extended. Then she's got to choose the drive. So 2-wheel drive, 4-wheel drive, 2-wheel drive, 4-wheel drive, 2-wheel drive, 4-wheel drive, 2-wheel drive, 4-wheel drive. How many choices altogether? There's 8 down here. Can you see that that's the same as 2 times 2 times 2? Okay, you have just discovered the fundamental counting principle. If an event M, choosing the engine, can occur in M ways, 2 ways, and is followed by an event N, let's say choosing the cab, that can occur in N ways, that's 2 ways, then the event M followed by the event N can occur in M times N ways. You multiply 2 times 2. And of course that can be extended to 2 times 2 times 2 if you have 3 events. Okay? So it gets a little bit more complicated and a little bit more fun as we go along. A briefcase lock has 3 rotating cylinders, each containing 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numerical codes are possible? Well, how many trials do we have? First, we have to set the first one. You know what? I'll do it over here in the picture. This is trial 1. Setting this one is trial 2. Setting this one is trial 3. Okay, how many different possibilities are there for trial 1? There are 10. Okay, same here, same here. So if we multiply 10 times 10 times 10, 10 cubed, that's 1,000 different possible passcodes. Try this one. How many 7-digit phone numbers can be formed if the first digit cannot be 0 or 1 and any digit can be repeated? Okay. How many different trials do we have? We've got 7, right? 7 numbers in the phone number. So how many different choices can go in here? It cannot be 0 or 1. Well, there's 8. How about for the rest of it? Doesn't really matter because repeats are just fine. So there are 10 possibilities for each of those. So we've got 8 times 10 to the 6th power, which is 8 million different possible phone numbers. Right? Take a look at this problem. How many 7-digit phone numbers can be formed if the first digit cannot be 0 or 1 and if no digit can be repeated? Well, that's kind of a silly problem because obviously you can repeat phone numbers. But this problem really highlights something that's important to know, the difference between an independent event and a dependent event. In the past example, because it was okay to repeat digits, we say that those were independent events. One event, whatever you get here, doesn't affect what goes here. Dependent events, as in this problem, mean that what goes here does affect what goes here and here and here and here and here. Those are dependent. Okay? So let's learn how to do that. Oh, first let's do some practice on, are these events independent or dependent? Choosing an ice cream flavor and then choosing a topping for the ice cream. Independent or dependent? Independent. The flavor doesn't influence the topping. maybe a little bit, but not technically. Okay. Choosing an offensive player of the game and a defensive player of the game in a professional football game. Well, I'm not a big expert on football, but I think that the offensive players and the defensive players are separate, right? So choosing one doesn't affect choosing the other. Those are independent. Let's try this one. From 15 entries in an art contest, a camp counselor chooses first, second, and third place winners. Well, now that's interesting. If the camp counselor chooses Joe to be first, can he be second place or third place? No. These are dependent events. The choice of the first influences what choices are available for the second and third. Let's try this one. Jillian is selecting 2 more courses for her block schedule next semester. She must select one of 3 morning history courses and one of 2 afternoon math classes. Independent or dependent? Independent. The choice of the history class does not affect the choice of the math class in this case. All right, solving problems that have dependent events still involves using the fundamental counting principle. Let's try this. There are 5 different routes that a commuter can take from her home to the office. In how many ways can she make a round trip if she uses a different route coming than going? All right, so how many events are there, or how many trials are there? Really 2, okay? This is on the way going, and this is the way coming home, okay? How many possibilities are there for going? There are 5 different ways that she can go. Once she chooses how she gets to work, that influences what's here because she can't go the same way. Can you see that there's only 4 possibilities left? If she's already chosen how she gets to work, there's only 4 possibilities left for how she gets home. So 5 times 4 using the fundamental counting principle equals 20. Let's try another one. In how many ways can the 4 call letters of a radio station be arranged if the first letter must be W or K and no letters repeat? Okay, we've got 4 different call letters. How many choices are there for the first one? Just 2. Okay. Once this one has already been chosen, how many choices are there for the second one? Well, how many letters in the alphabet? 26. One of them's already been used, so we've got 25 left. How about for the third letter? Well, 26 letters in the alphabet, but 2 of them have already been used. Fourth one? I bet you can guess. 3 of them have already been used. So how would you figure it out? You'd have to get your calculators out. 2 times 25 times 24 times 23. I haven't worked it out, but whatever that works out to, that's the answer. Let's try this one. Let me scroll down. The 10-member steering committee that is preparing a study of public transportation needs in its town will select a chairperson, a vice chairperson, and a secretary from the committee. No person can serve in more than 1 position. In how many ways can the 3 positions be filled? How many trials do we have? 3. Okay. Does an event in the first trial influence the second? Yes, because you can't have the same person being the chairperson and the vice chairperson. Okay, so how many choices we have for a chairperson? We've got 10. How many choices are going to be left for vice chairperson? Well, 1's already been used, so we've only got 9 choices left. How about for secretary? Well, if the chairperson and vice chairperson have already been chosen, we've only got 8. So 10 times 9 times 8 is 10 times 9 times 8. This one I can do in my head, 720 ways. Okay? Hopefully that's pretty clear. Thanks for listening.